Drawing? Hell, are we in art class or what? You remember what a straight line is, don't you? First, there are two vectors that are extremely important. They are the direction vector and the support vector. It's also good to know that you can use these to find a straight line between 2 points. The details of how this works don't really matter right now, but what we would be interested in is, how do you draw this stuff? Jace has a math problem. He should draw the point set that is delivered by the equation 1, 2, 3 plus k times 1, negative 2, negative 2. Just in case you're completely lost, what is a point set? It just means a straight line, because a straight line has an endless number of points, and every point on the line satisfies the equation. Why the hell is there a k this time and not a t? Relax, we did that just to confuse you. Remember, what we name the parameter doesn't matter, as long as it's there. Well, let's get going then. First, we draw our coordinate system. The y-axis to the right, the z-axis upwards, and the x-axis goes diagonally forward towards you. Now this is important, labeling the axis. Of course, you can do that however you want to, really, as long as it's consistent. Now to find the straight line. The first thing we do is, we draw the support point because that one is definitely on the straight line. It lies exactly where the support vector or position vector p is headed to, and its coordinates are given in our equation, 1 diagonal box forward on the x-axis, 2 to the right on the y-axis, and then 3 upward on the z-axis. Now we mark our point. Then we have 2 options to choose from. From this point, you can follow the direction vector r starting from the head of the support vector to find the other point on the straight line. Just use the coordinates for r in the equation. So, 1 unit forward, then negative 2 units to the right, or simply said, 2 to the left, and then 2 units downward. Then, you can mark a second point here, so the direction vector begins at our first point and ends at this point. Let's name this point Q, because, you know, we could also picture ourselves as zeros with little dicks. Well, except the girls in the team, of course. The straight line runs through the support point and the second point. 2 points clearly define a straight line, so you can connect those 2 points. And since a straight line can be infinitely long, you can draw it farther in both directions. You see, there's another way to do this, but this way is faster and takes less work. Those of you who aren't so lazy can try it the other way. You can calculate a second point on the straight line. Let's assign k a value of 1 in our equation. Then we can count and total up the vectors. This gives us the vector 2, 0, 1. That is the position vector to the point 2, 0, 1. Let's draw this now. You can see this is the same point that we got earlier. Marking the straight line, easy peasy. That was quick, but let's sum it up again. If you have to draw a straight line in space, first draw your coordinate system on the paper. Don't forget to label your axis, and think about the perspective when drawing your x-axis. Then, use the coordinates given for p in the equation to find the location of the support point and draw it. This point is definitely on the straight line, and its coordinates lie at the head of the support vector or position vector p. Then, you have a choice. You can follow the direction vector r from this point. Important, don't follow it from the origin. Wherever you arrive, that's where you mark the second point. And then, you draw a straight line connecting those 2 points. Or you can plug in a value for the parameter, which we called t or k, and draw the resulting point. If you use 1 for the parameter k, after working out the equation, you'll get the same point you would have if you had followed the direction vector from point p. Plot those coordinates, draw a straight line through the 2 points, and voila, you're done. Now practice this, and those exams will be a joke.